we may go back and forth as needs arise. Did you by chance go to that A+ math site at all?
No, not yet.
Okay.
I'm doing that
That's something that I would highly recommend you do on your own time, and just get to the point where you can do those single digit by hand.
Okay.
And more importantly, being able to add and so let's just talk briefly about adding and subtracting positive and negative numbers. What's that equal to? If you have a calculator, go ahead and do it on the calculator and see if you can get an answer. Because a lot of times calculators are pretty tough to deal with when you have positive and negative numbers.
Is that -16?
Correct. And the way I would do this is the subtraction sign. This is just a -7. That's all it is. And change the subtraction to an addition, which means you have to change the sign of the thing that was being subtracted. And now the problem becomes -7 plus -9. And that's clearly -16. When you're adding two negatives, the negative stays. As opposed to multiplying negatives, and then it becomes positive. All right. Let's go on and do some more algebra. Here's one. Trying to remember where our first session we left off on some of these problems. I don't think we did this one. Now these look hard, but they're not really. You just have to know how to cancel. Okay, so if we were going to do that problem, would we try to add these three fractions first? Or would we distribute this to each fraction? Which do you think we should do?
I think distributor.
Yeah, because, okay, so when you multiply this term by this term, what do you get? For starters, in other words, we'll simplify it in a minute. I'm going to write it down below. You get xyz in the numerator. In other words, xyz times 1 is xyz. And in the denominator, you get xy, which was still there. Okay? So you see how I get that? Okay. Do the same thing. Distribute it to the second term. What do you get?
X squared y z.
Okay.
And zy.
Okay. Is there any difference between zy and yz?
No.
No, there isn't. Okay. And the third term, you get what?
xy squared z.
Z squared. Right? In other words, it's z times z also.
Yeah.
All over
xyz.
xyz. Now let's simplify each expression. What does that simplify to?
Z.
What does this simplify to?
To xy.
Cancel
X
everything.
square.
Cancel. What is it?
X squared.
Correct. And this one?
To y z.
Okay. Yeah, and that's your answer. Okay. And notice when I did the last one, I actually really could have taken a big shortcut and canceled those three with those three so that I knew the answer would be just YZ. I wanted to do it completely methodical though. So, in other words, sometimes there are shortcuts you can take that are wise to take. Other times they're not. Because all they do is introduce possibility for error. All right, I think you're pretty good with that. How can I simplify the following? The very first, it's a factoring problem, is what it is.
Yeah.
Okay? And the very first thing you want to ask yourself on a factoring problem is there a greatest common factor that I can remove for starters? What is it?
X.
Okay? So I can take out an X. What's left? When I say what's left, I mean after you divide each term by X, what do you have left?
X plus Y.
Plus 1. In other words, I have to divide that by X, I have to divide that by X, and I have to divide that by X. So this is where you get the X, this is where you get the Y, but this is equal to 1.
Okay.
So that's the answer factored. Okay. Let's talk about difference of squares. We're going to talk about factoring for a while. Because if there's one thing you really need to be able to do on that test is factor a quadratic usually. Let's talk about another way of factoring. In other words, the first step for factoring is greatest common factor. Okay? And we were just doing some of those. Let's do one more. Take out a greatest common factor from that expression. What's the greatest thing that can divide evenly into both expressions?
2.
What's left?
X plus 3. Yeah.
Okay. That's greatest common factoring. Now we're going to talk about difference of perfect squares. We're just going to go through some methods of factoring, and then you'll be able to factor most anything. If I have a squared, no matter what a is, minus b squared, I have the difference of perfect squares. And that always factors into this. For example, if I had x squared minus 4, that would factor into x minus 2 and x plus 2. Okay, see how it works?
Yeah.
Tell me what this is. In other words, the way you get that term right there is to take the square root of that term. The way you get this term, it's always minus plus, but to get each of the terms, you take the square root of that term. What's the square root of 4x squared? when you take the square root of something, the answer needs to be something that when you multiply it back together again, you get 4x squared. So what number multiplied by itself is going to equal 4x squared? What number and or variable?
2.
2x.
Okay.
The reason is 2x times 2x equals 4x squared.
Yeah.
Okay? So you need to be able to take square roots of stuff. Let's talk about, so anyway, let's finish this problem. So what goes here?
3.
And what goes on the other side? You don't even need to think about it. It's just the conjugate of that.
2x plus 3.
Right, okay. Let me test your square root knowledge. In fact, a really good thing to know is squares. In other words, you don't want to have to go to a calculator to do this. What's 2 squared? In other words, if I take the number on the left and square it, what do I get?
4.
3 squared?
6. 9.
4 squared?
16.
5 squared?
25.
6 squared?
36.
7 squared?
49.
8 squared?
64.
And 9 squared?
81.
Did you do all those in your head, or did you have to use a calculator on any of them?
I use the calculator.
Okay. If you're going to memorize any part of your multiplication tables, this is the thing to memorize for sure. How to square a number without a calculator. And it's just, it's memory. That's all it is. Okay? And then, of course, now if I took the square roots of each of these, square root of 4 is
2.
Square root of 25 is
5.
You get the picture?
Yeah.
Okay. So you need to be able to take square roots. And I would say you probably need to be able to do it without a calculator. It's the problem with doing all of this arithmetic without a calculator is that's going to be quite a bit of work for you. You know, you're talking about a couple of years worth of education on basic arithmetic and stuff. And you can get by perhaps without being able to do it in your head. I don't know. Every student I work with in high school that I find has basic problems with their math skills, their arithmetic skills, I really try to get them to perfect those. And it's amazing how effective that is at getting them better at algebra and geometry. It is really hard to do algebra if you don't know how to do this stuff in your head. It just is. And it's hard to explain why. So I just can't highly recommend you going on to A+ math 5 or 10 minutes a day and just practicing. And you'd be amazed at how quickly you will pick them up and learn all of them. Let's go on. So we know how to take square roots. What's the square root of x squared equal to?
X.
What's the square root of x to the 4th equal to?
X squared.
Okay, good. So we were talking about difference of perfect squares. Well, sometimes it doesn't quite come in a nice package, but this is a two-step problem. In other words, what's the very first thing you can do? If you're looking to factor this,
Divided by 5.
Correct. Factor out of 5. What do you have left?
X squared. 1, not minus 1.
Now, notice what that's called. What's the name of that? It's helpful to memorize the name of this because you're supposed to be able to recognize it whenever you see it. Difference, it's dopes. Difference of perfect square. Remember that.
Mm-hmm.
Okay? And so how does it factor? In other words, that's the a square. 1 is a perfect square. Most people don't remember that 1 is actually a perfect square number. That's the square root of 1 is 1. So this factors how? Just this part of it?
It's x minus 1 and x plus 1.
Good. And so that expression factored into 3 things. Okay.
Mm-hmm.
What's that called?
Dope.
Mm-hmm. Difference of perfect squares, right? I'm the only one that refers it to dopes. I just came up with that just to hopefully make it easier to memorize. But you really want to memorize it as difference of perfect squares. Because notice that's what it is. That's a perfect square. That's a perfect square.
Yeah.
Okay. If I had something like this, well, that's neither one of those is a perfect square.
Yeah.
So I wouldn't be able to apply it. We have to have perfect square numbers. So what's the answer? Remember, to get this, we need to take the square root of that. And to get this part, we need to take the square root of that.
Mm-hmm. X squared minus x. X squared plus x.
Okay. All right, now let's talk about another type factoring. When you have a quadratic expression, particularly in standard format, and this is in standard format because the x squared's in first, the x term is next, and then the term without an x, the constant, is next. Mm-hmm. Okay? And there is a particular way to factor these. I'm going to teach you my method, and there's varying degrees of difficulty of these, but I think you can probably get by on the GRE pretty well with just being able to do the ones that have a 1 as a coefficient in front of the x squared term. Mm-hmm. That makes all the difference in the world. In other words, that makes it easy. If I had a 2 there, then the problem becomes much more difficult. But let's get you proficient at doing these where there's a 1 in front of this. Okay? And it might be helpful for you to write steps. Step 1. Separate the x's. You do that by putting an x there and an x there. Step 2. Determine both signs. And by that I mean plus or minus signs. Okay? Well, the only way when I multiply, in other words, what we're doing is reverse multiplication. In our last session or our first session, we talked about how you multiply a binomial by a binomial. You use that expression called FOIL, where you multiply every term by every term. Well, this is going backwards. That's all it is I'm taking a quadratic and separating it into two linear terms. Well, the only way I can get a plus 9 here is if both signs are the same. So when I see a plus in front of the constant, I know that both signs have to be the same. They either have to be negative, negative, which would produce a positive, or they have to be positive, positive, which would produce a positive. And the one you choose is the sign of the middle term. Since it's plus, this has to be plus, plus. Okay? And determine both signs at once. Step 3. Factors of the constant, which is 9, that in this case add, because of that plus sign, add to the coefficient of the middle term. So I'm looking for factors of 9 that add to 6. What is that?
3.
3 there and 3 there. Okay?
Yeah.
And so that's what we've done, is we've separated that into these two. Now, just to make sure we've done it right, let's multiply these two together and see. What's the first term?
X2 plus X3.
Let's put the coefficient in front, 3x.
Okay, and then plus 3x plus 9.
Okay, and now we can always combine those two middle terms. Well, not always, but most of the time.
Which is going to be 6x.
Right, and that's what we started with, which means we factored it properly.
Yeah.
Okay?
Yeah.
That's as easy as they come. And I'll show you a slightly different one with a minus sign this time. Okay? This minus sign is going to make a difference. Have you learned factoring before, Manira?
Yeah, but I'm now remembering it.
Okay,
So.
okay, that's fine. Okay,
So
step 1.
Separate the x's, so it's going to be x here and x there.
Step 2.
The sign is going to be minus.
I'm sorry, what?
The sign is going to be minus.
Notice that if they were both minus, this would have to be plus. Because the last step in multiplying these two things together is to multiply minus a number times minus a number, which would be plus, which means they can't be both minus. They have to be opposite. One has to be minus, one has to be plus.
So if it's positive, they're going to be positive. But if they're minus, one has to be minus and one has to be plus, right?
Almost. If it's positive, they could both be negative. We'll get to one like that. You'll see.
Okay.
Okay? But first of all, let's handle this situation. Okay, so we got steps 1 and 2 done. Now, step 3 is we need factors of 10, but instead of adding to the coefficient, they need to subtract to the coefficient because of that minus sign. So let's say add or subtract, depending on what that sign is.
Okay. Is it 12?
This case, they need to subtract to the number 2.
Yeah.
And just the absolute value of the number. Don't worry about the sign yet.
Okay.
So what are the two numbers?
12.
5 and 2. I need factors of 10. When I say factors of 10, I mean two numbers that multiply to 10. Okay? And they have, excuse me. I meant to put a 3 there. Sorry, I didn't mean to confuse you. Okay, so I need factors of 10 that subtract to 3. Well, that's 5 and 2.
Okay.
Okay, and because of this negative sign, there is a step 4. And step 4 is put the larger of the two factors, with the sign of the middle term. With the sign of the middle term. What's the sign of the middle term?
Positive.
So I'm going to put the 5, the bigger of the factors, with the positive. And the 2 goes there. Okay. Now, when you have factored a quadratic expression, you frequently want to check to make sure you've done it right. But you don't really need to do what we did last time. Last time we completely multiplied the expression back together again and to determine whether we had the right one. You may want to do that the first couple times. But after you've done this a while, you realize that you really don't need to double check that term. The step 1 was separating the x's. We're not going to make a mistake there.
Yeah.
Okay? We also don't really need to check that term. Step 3 was factors of this number. Well, as long as our factors are correct, we've got that checked. In other words, we know that this thing is going to produce an x squared and it's going to produce a minus 10. No question about that. What we're not sure about is the middle term. So whenever I check my work, I'm going to add the 2 middle terms and the 2 outside terms. In other words, in the FOIL, I'm going to check that one and that one because those two, in other words, the inside and the outside, that's what the O and the I stand for. And those two combine to create that middle term. So that's the one I'm really concerned with. So 5 plus 5 times x is plus 5x. Minus 2 times x is minus 2x. Add those together, you get plus 3x. That is our middle term. We did it correctly. Okay? All right. Turn that back to a plus. Turn that to a minus. That looks like a cross. Let me make it a plus. Okay? Slightly different situation. But there's only a finite number of these situations. After a while, as long as you go through these 4 steps, you're going to be able to get it. Okay, so it's step 1.
Separate the x's. X and there.
X and x. Step 2.
The sign, which is going to be
both signs. What are they going to be?
Positive.
Well, if they were both positive, it would definitely produce that. But it's not going to ever be able to produce a middle term that's negative. So all that positive means is that both signs are the same. If you want to know what they are, look at the middle term. The middle term's a negative, therefore both signs have to be negative.
Okay.
Okay? And notice that will produce a positive 10. Okay? Step 3. In this case, we want factors of 10 that add, because of that positive sign, to the number 7. Not to negative 7, but to the number 7. Well, again, that's 5 and 2.
Yes.
Okay? And in fact, whenever this is a positive sign, you don't need step 4.
Okay.
You only need the first 3 steps.
Yes.
Okay? And if I'm going to check to see this is right, I do my double smiley face check. That's minus 5x. That's minus 2x. Add those together, you get minus 7x.
Yes.
We did it right. Okay. Trying to think if there's any other combinations. Let's see. No, I erased them all. Let me think for a moment. Yeah, let me give you a couple to practice on. Ooh, there's that hissing. Don't know what causes that. All right, this time I'm going to let you go through all 3 steps on your own and just tell me what the 2 factors are.
Okay, so first separate the x's. This sign is going to be positive.
Both signs.
Yes.
Okay.
And the factors is 5 for both of them.
That's it.
And if you want to check it?
Well, yeah, you can check it if you want. This is an easy enough one. It's pretty easy to check. You don't necessarily have to check it on paper. In other words, as long as you can do this in your head, you know that that's 5x plus 5x is 10x.
Yeah.
Okay, so some of these you can check in your head. Here's one that's a little different.
Oh.
Yeah, we're not used to seeing them with fractions in there. Separate the x's. What are the signs?
Positive.
Now, what 2 numbers multiply to 1/4 and add to 1? Remember, they need to add to the coefficient of x.
1, 2.
Not to x, but to the coefficient of x. What'd you say?
1, 2.
1/2.
Yeah.
Yeah, that's 1/2 or 1/2.
Okay.
And notice that works. That gives you plus 1/2 x. That gives you plus 1/2 x. Add those 2 together, you get plus 1x. So that produces the right middle term, and 1/2 times 1/2 is equal to 1/4. Okay. Now, what's our first step here?
Separate the x's.
Okay, we could do that. How would I separate them?
It's going to be 2x and 2x.
Well, that would give me 4x squared. So if I'm going to separate them, it's got to be 2x and x.
Yeah.
Right?
Yes.
Okay. And now if I were to determine my signs, what are they both?
Minus.
Correct. Now, here's a problem. This is what I call a second-order quadratic. In other words, it's got a number in front of the x squared other than 1. This makes factoring it much, much harder. In other words, we can no longer use this step 3. I can no longer say factors of 8 that add to the number 8. It doesn't work because one of those factors is going to be multiplying 2x, the other factor is going to be multiplying x. So whenever you have a second order quadratic, step 3 is different. And I'm not going to talk about how to do this problem. I just wanted to show you that whenever this thing is not a 1, these become far more difficult. At this point, it becomes trial and error. And by that, I mean I'm going to experiment with factors of 8 and see if I can get it to create this middle term of minus 8. Okay, well, could I do that? Yeah, probably if I use 2 there and 4 there. Okay, in other words, I've got factors of 8. Do I produce the proper middle term? Well, let's see. Sometimes this isn't just a check. Sometimes this is a way to figure out the answer. I do produce the proper middle term. So this is correct. Okay? But it was kind of a trial and error. And you'll notice that I can't say factors of 8 that add to the number 8. 4 and 2 don't add to 8.
Yeah.
So step 3 is different. Let's step back a moment, though. We managed to do this using a bit of trial and error, and that's what you use. But notice that there's one thing we could do to this problem to make it far easier right off the get-go. What's the very first thing you try to do when you're factoring something? If I go back to my start, greatest common factor. Okay? In other words, see if we can find a greatest common factor, because we might be able to make this thing into a first order quadratic, which is going to mean we can use these 3 or 4 steps to solve it. What can I take out of all 3 terms?
8.
8 does not divide into 2. Remember that in order to factor something out, it has to divide evenly into each of these terms. You're getting it backwards.
With 2, then 2.
2 is correct. Okay, what does 2 leave behind?
X2 minus 4x plus 4.
Now notice what we have. Now we have a first order quadratic, which is pretty easy to factor. You can't forget the 2. The 2 has to come down. But factor that.
X. And X there. And the sign is minus. And the number is 2.
2 in both spots.
Yeah.
Notice how much easier it was to get to this answer. Now, you might notice that it's a different answer, but if I were to multiply the 2 times that, I would actually have 2x minus 4 times x minus 2, which is the answer we came up with when we did it the hard way. Okay? But when you're factoring stuff, you always want to take out all factors. In other words, I would never give this answer. Ever. Because I can take a 2 out of that. In other words, this answer here is fully factored. This answer here is not fully factored. You can still factor a 2 out of this first linear expression. So always your first step is to look for a greatest common factor, because that might just make the problem easier, the factoring of it easier.
Yeah.
Okay, so if we go up to our types of factoring, we have greatest common factor is the first thing we always consider. Second thing we always look for is difference of perfect squares. and then what is just called factoring. Both of these are called factoring also, but this doesn't have a special name. I'll give the example just so you know what we're talking about when we say factor, and that's equal to x plus 5 times x plus 2. Usually when people talk about factoring, they're referring to the bottom thing here. They're not really usually referring to difference of perfect squares, although that certainly is factoring. Notice that we take an expression. The only difference between that expression and our bottom one is this doesn't have an x term in it. In other words, this only has x squared. This also has to be perfect squares. I can't use this if it's not perfect squares. Okay, let's see. Let me look at some more of these problems here. All right, let's go on. Let's do our basic level algebra level 1 test. And I've done some of these. Let's just review. If I don't know if you wrote these steps down or whatever, but as I said, I'm recording this, so you'll always be able to find this again.
Yeah.
Okay. Let's just do some simple algebra equations. We might have even done this one, but that's okay. Let's do it again. This is a basic enough one that I can apply the main rule of algebra equations, which is to gather all like terms on one side of the equation and put all numbers on the other. So if I want to gather my x terms on the left side of the equation, what do I have to do?
3x minus x.
Correct. In other words, I have to subtract an x there to get rid of it, which means I have to do the same thing over there. Now that gives me 2x plus 1 equals 0, because x minus x is 0. What's the next step?
2x is equal to minus 1.
And the last step? In other words, the goal is always to isolate x. Your final step is always going to be x equals something. What do I have?
Minus 1 equals 2.
And the way you isolate x...
Divided by the number.
Right, but there's... I was going to say just a little bit more than that. If you have something being added to x, then you have to subtract it. If you have something multiplying x, then you have to divide it. In other words, you always do the opposite of what's being done. Let's do this one. First step. What I usually ask people to do is read me the next line.
Okay, so it's going to be minus 2x equal to 10.
And the next line.
It's going to be minus x, or x.
Why don't... the reason I wrote x is, I see what you were doing. You were dividing by 2. But let's divide by minus 2.
Yeah.
In other words, if we divide by minus 2, we will isolate the x immediately.
Yes.
So
that's the x equal to 10 over minus 2.
Which is?
Minus 5.
Mm-hmm. Good. All right. Let's take a more complicated one. Funny, that noise almost seems to come when neither one of us are talking. If
Yeah.
one of us are talking, it seems to go away.
Yeah.
But the moment there's quiet, it's almost like there's background noise that gets amplified when we're quiet. All right. So I want to know what this thing is equal to, meaning after I've simplified it. What's my first step?
It's gonna be 5.
Well, normally I want you to just read the next line. But here I'd like you to tell me conceptually what your first thing you're going to do is.
I think we put the numbers like in the other side and the...
Not quite. The first thing I'm going to do is distribute this. In other words, my first step is going to be to get rid of the parentheses.
Okay.
Before I can combine everything, I've got to multiply z by both of those terms. Okay? And rather than rewrite everything, I'm just going to do it right here. Minus, what's z times 3z?
3z squared.
And what's minus z times minus 4? Actually, I said it wrong. The first time it's minus z times 3z. That's minus 3z squared.
Yeah.
The second part is minus z times minus 4. What's that?
Positive. It's going to be positive 4z.
Okay. So I've eliminated the parentheses, and I still have, I'll go ahead and write those terms just to avoid confusion. So now that's what I have. Now I have no parentheses, I have no denominators. That's kind of my first two things that I try to get rid of whenever I'm solving an equation or simplifying an expression. Is if I can get rid of the denominators, I do, but definitely want to get rid of the parentheses. Now combine everything. How many z squareds do we have?
2.
How many z's do we have?
2.
Well, what do they total? Ah, I see. You just got lucky on the first one.
Yeah.
Because we got a z squared there and we got a z squared there. But when you total them, you get 2.
Yeah, it's going to be minus 9. Minus 2?
Well, we got a minus 5z and a plus 4z.
It's going to be minus 2, yeah.
Okay, that's minus 5 plus 4.
Yeah.
That's minus 1.
Okay.
Okay, here's the thing. When you are adding a positive and a negative number, let me just go over this with you. If I'm adding minus 5 plus a 4, I am going to, plus a plus 4, I'm going to always subtract the two numbers. So that's equal to 1. And then I'm going to put the plus or minus sign of the bigger number. Well, the bigger number is 5, so I've got to put a minus with that.
Yeah.
That's the easiest way to add a positive and a negative number.
Yes.
All right. How many numbers do we have?
4.
Okay. Now, is there a greatest common factor I can take out of that?
Yeah, 2.
No? This is a z, not a 2.
Not 2, no, there's no.
So 2 does not divide into that, right?
Yeah.
So there is no greatest common factor. Let's see if we can factor it. It may factor nicely, it may not. This is a second-degree quadratic. So break up this into what?
To 2.
2z and z.
Yeah.
Okay? The very first time you break it up, always multiply it right back together again to make sure you got the same thing.
Mm-hmm.
That's the best way to check stuff, is to
Mm-hmm.
check it as you go along.
Mm-hmm.
What are the signs?
Minus.
Both minus.
Mm-hmm.
And I've got a couple of choices on 4. There's 1 factors, and there's the other set of factors. And I can't use any of the rule. I can't use my step 3 rule because this is a 2 and that's a 1, so that rule goes out the door. So I pretty much have to just randomly try stuff. Well, if I try 4 and 1, hold on, let me go back a moment. What I tell all my students is the first things to try are the 2 closest factors together.
Mm-hmm.
Does that produce the proper middle term?
No.
Okay. So the only other choice is to try a 4 here and a 1 there. Does that produce the proper middle term?
Yes.
No. Produces minus 4z, minus 2 more z, that would be minus 6z. We're looking for a minus 1z. So 4 and 1 don't work. The only last remaining choice I have is to put the 1 on the left and the 4 on the right, and that produces minus 9z. So this thing does not factor into integers. In other words, there are no whole numbers I can put here that are going to multiply together to give me this. So if it doesn't factor, I'm not going to factor it. That is actually the answer in the book. It's a multiple choice, and this is one of them. Okay? So sometimes you end up with a quadratic that does not factor. Let me go back to the standard one I've been talking about. X squared plus 7x. If I said plus 9, notice I can't do this. I got x, and I got plus and plus, but factors of 9 that add to 7, they don't exist. The only factors of 9 are 9 and 1 and 3 and 3. And 9 and 1 certainly don't add to 7, and 3 and 3 don't add to 7.
Yeah.
And so if I really need to know the answer to this, in other words, if this was an equation and I needed to figure out what value of x makes that equation true, I have to use something called the quadratic formula. I'm going to write it to you because you've probably seen it, is my guess, but you've probably not memorized it, and I'm not even going to ask you to memorize it. Have you ever seen this?
Yes.
Okay. This is what you use to solve quadratics that cannot be factored in any other way. The a is the coefficient of that. That's a. The b is that. And the c is that. Actually, the b covers the sign also. So, I don't think we need to go through this yet, because I'm not sure, I don't think on the GRE you need to be able to do the quadratic formula. So let's not spend time doing it. The only reason I brought it up was there are plenty of quadratics out there that can't be factored. And when you can't factor them, you can still solve them. It's just harder. You have to use that quadratic formula. Okay? All right, let's see if I can impart a bit of wisdom with 2 minutes remaining here. just make sure you can do this problem. When A is equal to -1 and B is equal to -2, what is the value of this expression? So, let me show you the best way to do it. Don't try to solve it all at once. Merely plug it in exactly as you see it. In other words, I'm going to put a 2 there for that 2. And in place of A, I'm going to write -1, but I need to put it in parentheses because I want to make sure the -1 is squared. Incidentally, this means different than this. When I write that, the square only applies to the number. It does not apply to the sign. So the answer to the left side is -1. But the right side, it's -1 times -1. The answer to that is +1. So these parentheses are necessary. When you're going to substitute numbers for variables, always use parentheses. In other words, A is still -1, B is -2, and B is -2. Okay, so my very first step is all I've done is substitute in parentheses, and now my second step is going to go through and simplify this. First thing to do, get rid of the parentheses. What does this become when I get rid of the parentheses?
3.
No? Do the parentheses first. What's -1 squared?
+1.
What's +1 times 2?
2.
That's what that is. Now, let's get rid of those parentheses. What is -1 times -2?
2.
Correct. 2 times -2?
-4.
And finally, let's get rid of that parentheses.
4.
Add it all together, what do you get?
4.
No, the 4's cancel. In other words, -4 plus 4 goes to 0. You're left with 2.
What about if they are the same sign, like +4 and +4?
Then it would be +8.
Okay.
In other words, if I made that a plus, then it's 2 plus 4 plus 4, that would be 10. But if that's a minus, the best way to do it when you're adding 3 numbers is not to go 2 minus 4 is -2, but it's to look at this part first and realize that that goes to 0.
Yes.
That's equal to 0, excuse me. And so the answer is your only remaining number, which is 2. Now, let me just say something before I leave you. When you are using parentheses like this and negative signs, it's very easy to accidentally think you're subtracting instead of multiplying. Right? There is only one subtraction taking place here, and that's that one right there.
Yeah.
Every other negative sign you see is a negative sign. It is not subtraction.
Yeah.
And so, but the problem is if you make these negative signs too big, it's easy to think that it's 2 minus 1 minus 2. In other words, to forget there's parentheses there. And that's why my first step is always get rid of your parentheses. And then you know exactly what you're dealing with. Okay? All right, I will leave you with that. You feel a little bit better about the algebra session than you did about the first session, probably?
Yeah, much better.
Yeah. Yeah, you know more algebra than number
Yeah.
properties. At some point, we'll go back in number properties and review them, but
Mm-hmm.
I don't want to demoralize you from the start. Um, So, starting with algebra, going through algebra, maybe going through geometry, and then we'll go back and talk about the number properties if we still have time to do so.
Okay.
Okay?
Yeah.
All right. Let's see. You got my link. Did you have a chance to review the file at all?
Yeah,